Hello, this is the demonstration of JS-Distributor, a tool that can help to decompose monolithic applications into microservices. To use the tool, all you have to do is add the proper dependency into a Node.js project, as we will do right now. Now we will proceed to create our monolith. Our monolith is composed of three functions: for getting a message based on two parameters, greeting and person, getting the full name based on first and last name, and running the application. I also exported this main function so I can use it in another script that I will create right now. Okay, now I can run the monolith so I can see the output. As you can see, the application executed normally. Now we will use JS-Distributor to decompose this application into microservices. We will do so by creating a configuration file. We start by defining some code generation parameters. Now we proceed to describing how many servers we want. I will split this monolith into two servers, alpha and beta. Okay, so we have three functions in our monolith. I will do as follows. I will keep main in the main server, and I will put get message and get full name into beta server. As you can see, for the alpha server, I did not configure any function, and for the beta server, I configured some parameters. It will run in the local host address in port 3000, and it will contain two functions, get message and get full name. Now we can run the tool. This folder was distributed, with two folders, alpha and beta. JS-Distributor copied the entire folder for the monolith into these folders, but it replaced all the remote functions for their remote calls. For example, in the beta server, which hosted get message and get full name, these functions still appear here normally. But in the alpha server, which does not have this function, they were replaced by remote calls. So for get message, we have a fetch, and for get full name, we have another fetch. For the first one, as you can see, we have a get request being made, because this is how we configure get message in our config file. For the get full name, we have a post fetch, because that is how we configured in our file. JS-Distributor also generates a startup code for the servers. For example, here we can see the code for the beta server, where we set up the get message function as a get endpoint and get full name as a post endpoint. Now we can execute our new application. Okay, so it's now running on port 3000, and then we can run the alpha server. As you can see, we have the exact same result, but now distributed in two servers. In the alpha server, we can see the main function being executed, running application, and the message. But the message for the getting full name and getting message, which are located in these functions, are on beta server. JS-Distributor allows researchers and professionals to freely experiment with different configurations of microservices. For example, let's now put this function into another server, so we will create a three-server architecture. Okay, so now I created a new server called Gamma in our config file. It will run on port 3001 in the same host, but we moved the get full name function to this new server. We also changed the get message function to run as HTTP post instead of get. With the new configuration, we can run the tool again. As you can see, now we have three folders, alpha, beta, and gamma. And now we can run again so we can test the new architecture. Now we can see that the main function still runs in alpha server, beta server runs the getting message function, and gamma server runs the get full name function. We tested JS-Distributor with acme-air, an open source repository that is commonly used in microservice research. This is an open source project that we adapted and ran locally. So this is acme-air running as a monolith application. As you can see, load the database. We can use it to simulate booking flights. As you can see, our flights appear here. And this is all running as a monolith. And this is acme-air running on 4 servers, totally generated by JS-Distributor. As you can see in the 4 windows below, there are messages from all servers indicating that they are cooperating to function together. And to spice things up a little, we try to run acme-air in 10 servers. As you can see here, we have 10 nodes communicating through HTTP GET, HTTP POST, and Rabbit asynchronous messages. And this is Acme Air running on 10 servers. As we can see below, all servers cooperate to deliver the same functionality as the monolith. Not a single line of code had to be modified, as JS-Distributor generated everything for us. This demonstrates how JS-Distributor can help researchers and professionals to experiment with different architectures more easily, allowing evidence to be based on actual deployed services. Thank you.